Hello everyone. In this video, I would like to go over the 4 basic mathematical operations of complex numbers. The 4 basic operations are addition, subtraction, multiplication, and division. In this video, I will concentrate on the rectangular form of the complex number and also the polar form of complex number. These two forms related to the operations that we are going to work with. The rectangular form of a complex number consists of the real part and the imaginary part. The imaginary part of a complex number has something to do with the j. J is defined as the square root of -1. We raise j to the exponent 2, we end up with a -1. J is an imaginary number because if you square a number, you should not have a negative as a result. However, in this case, j squared equal to -1, therefore it has a special name as imaginary number. Attached to the y, it will become the imaginary part of the complex number in rectangular form. As you know that you can use your calculator to convert between rectangular form and polar form. Polar form of a complex number consists of the modulus and the argument. The argument in this case is measured in degrees. Alright, so if we are going to add or subtract a complex number, we need to put it in rectangular form. The simple way to deal with addition and subtraction of complex number is to convert whatever given to you into rectangular form, and then from there the operation can perform using algebra. For multiplication and division, we need to use polar form, and also it is the most simplest way to perform operation with multiplication and division with complex number. So the rules are as follows. So if we multiply two complex number in polar form, you are going to multiply the two moduli, but you are adding the two arguments. So if you divide two complex number and you put them in polar form, then you can apply this rule. You divide the two moduli, but you subtract the two arguments. So there are methods for you to multiply and divide complex number in rectangular form as well. However, they are complicated. In this particular video, I just want to simplify and show you the simplest way to perform these operations. Alright, so let's work with a few examples. So for this particular question, it asks us to perform the indicated operations, express final answer in polar form, and we work with 3 decimal places and round final answer to 3 significant digits. So we are going to take a look at the operation in this case. The operation here is asking us to subtract these two complex number, but this two complex number is given to us in polar form. So if we go to this above rule that I mentioned earlier. So for addition and subtraction, we should use rectangular form and apply algebra to it. There isn't any rule for addition and subtraction if our complex number is given in polar form. Therefore, the best way is to convert this to rectangular form. Alright, so I'm going to ask everyone to convert to rectangular form. And we are going to use the calculator. Okay, so any calculator that you have should have the function that you can convert a complex number from polar to rectangular. So what I'm going to do is I will just use my own calculator and give you what number that I found. Alright, so for this particular number here, this complex number in polar form, when I convert that, I end up with -3.738 plus 1.937j. Okay, we put that in the brackets. So when we convert this complex number, we are having this number here. Put it in the brackets because you might end up with a negative. Okay, so negative 1.541, add that with 3.275J. So at the same time, I would like you to use your calculator and review the concept of converting from polar to rectangular form and make sure that you get these numbers. Now I'm going to use algebra, right? So in algebra, I can add or subtract like terms, but before I can do that, I should open up the bracket. That means I multiply this inside the brackets, the negative inside the brackets, and then I should have, I just repeat, writing these, the first two numbers, then negative will give me a plus 1.541 and subtract that with 3.275J. So basically, when you subtract two complex numbers, you in polar form, you convert to rectangular form, and at this point you treat it as an algebraic expression and you collect the like terms. So when you collect the like term, what I have is I will collect this with this, right? Okay, so when I add, when I have negative 3.738 and add that with 1.541, I am having negative 2.197. And if I collect this and this as like term, I will have negative 0.338J. But the question asked me to convert this one into a complex number in polar form. So what I have done is I use my calculator to convert to polar form, and I also round it to 3 significant digits. So this is the answer that I got on my calculator. 2.57 as the modulus, and the argument is negative 149 degrees. So make sure we indicate the degrees. Alright, so let's move on to the next question. So this question asking me to add this two complex number, but again is given in polar form. Okay, so when it's given to us in polar form, the easiest way or the only way for us to add these two complex number is to convert that to rectangular form. So I will convert this to rectangular form. I will also convert this to rectangular form. So again, I use my calculator and then I have rounded to 3 decimal places. Okay. And then again, the same concept, I will collect like term. Since this is just a plus, so I don't have to worry about this at all. It's all as a plus sign. So I should have 12.682 plus 4.744J. Again, I will use my calculator to convert to polar form, and then at the same time, I round to 3 significant digits. And I make sure that I give the degree sign for my argument. Okay, so let's move on to the next question. Okay, so this question asking me to divide these two complex numbers, and again it's given me in rectangular form. I can tell you that there are ways for you to divide these two complex numbers and keeping this in rectangular form, and you must use the concept of conjugate. However, I will not go over this in this particular video. I just want everyone to apply this simple concept of converting this to polar form and then perform the following operations according to the formulas. Okay, so what I'm going to do is I will convert the numerators to polar form. So when I convert this to polar form, I have the answer as 8.656 and the argument is 123.360 degrees. I'm keeping it as 3 decimal places. So for the denominator, I have this negative 36.570, and the final answer I get should be, I will write it as this. So I will write it as A.656. I divide this with 9.550 and I will present the argument as this. Okay, so I recommend that everyone follow this. You see this here, we have a negative as a denominator and we subtract a negative argument. So we need to take the negative into consideration. So when I divide this two number, I end up with 0.906 as 3 significant digits. Don't forget, this and this turn into a plus. That means you are adding this 123.360, add that with 36.570, so you end up with 160 degree. But I must present this as 3 significant digits, so I must put a power on top of the 0. So this one is 3 significant digits, just to remind everyone. Alright, now, so for the next question, I have to multiply these two complex number, but now it's given to me in rectangular form. I can tell you that you can use, simply using algebra, to expand this two bracket and then go from there. However, in this video, I just want everyone to apply this concept, which is when you multiply two complex numbers, the best is to convert them to polar. Then you multiply the two moduli and then you adding the two arguments. Okay, so I am going to show that I will convert to polar form for the very first complex number. I end up with 6.422. The argument is 75.942 degree. And then I multiply this with this number. When I convert, I have this on my calculator. Okay, so now I'm going to use my the formulas are given to me. I multiply this with this. Okay, and for the argument, I'm going to add them. And then I add that with negative 0.106.142 degrees. So when I'm adding this, I end up with 41.1. I mean, adding this argument, I will have negative 30.2 degrees. But multiply this two number, I will have 41.1 as 3 significant digits. Okay. So in conclusion, for this particular video lesson, what I would like everyone to remember is to understand complex number in both rectangular and polar form. And then the 4 basic operation of complex number falls into either rectangular form or polar form. So for rectangular form, it's best that we use it to apply to addition and subtraction because we can treat as like term and then the operations can perform using the basic concept of algebra. For multiplication and division of complex number, we apply polar polar form to this complex number, and then we use the formulas that given to us. I also would like to tell everyone that there are methods that you can use to multiply and divide complex number in rectangular form. However, they are not going to be covered in this video. Okay, so the purpose of this video is to lead to our next lesson, which is the calculating the total impedance for AC, ILC circuits. All right, and in order for me to calculate the total impedance, then I simply apply this rule that I just show everyone. All right, okay. I will simply apply this rule that I emphasize the simplest way to perform 4 basic operation of complex number. All right, thank you everyone.